Welcome to the TAM Customer Webinar for June 2024. We're delighted to have you with us today. This session is brought to you by the TAM organization, which is dedicated to providing our customers with a platform to engage with great speakers and gain insights that will maximize the benefit of your VMware by Broadcom software investments. A few important notes before we dive into the content. We want you to mark your calendars. Our upcoming TAM Customer Webinar is scheduled for June 11th. Where we'll dive into the use cases and architectural design of Edge Compute Stack, exploring its capabilities and provisioning and comprehensive lifecycle management. Should be a great session. Please be on the lookout for an invite from your TAM for this upcoming session. Also, your voice matters. We encourage you to actively participate using the Q&A feature here for any questions that you may have. And should there be any unanswered questions, please contact your TAM for further assistance. We want you to share your thoughts at the conclusion of this webinar. We invite you to complete a brief survey consisting of a few questions, and your feedback is invaluable to us and greatly aids in enhancing the quality of our future sessions. And of course, we want you to be able to review these later, so this webinar is being recorded for your benefit. Your TAM will provide you with the access to the recording, which will also be made available on the TAM YouTube channel in the coming months. So with that, I'd like to introduce our speaker. Today, we welcome Jason Massae, a technical marketing architect within our VCF division. Jason has an extensive background in technology that spans multiple domains, including enterprise architecture. He's influenced product roadmaps, and he helps our teams develop enterprise solutions. His current focus is on VCF core storage, which includes vVols, and we are thrilled to have him share his insights with us today. So Jason, thanks so much for joining us. I'll hand it over to you.
All right, thanks. Welcome, everyone. So today what I'm going to do is I'm going to go through the core storage and vVols updates, starting with vSphere 8. So this will really help to give you an insight into all of the areas that we're focusing on and all of the features that have been added with each release. So like Chris said, if you have any questions, throw those in the chat, and I'll probably stop per section and see if there's any questions. And then at the end, if there's more questions, we can also dive into those. So let's get started. So first, we're going to dive into vSphere 8. Now, I'll probably do some allusions to vSphere 7 where there was some feature adds, but for the most part, I'm going to start with vSphere 8 because that's where a lot of the really advanced features have been added to core storage and vVols. So you're going to notice a theme here. And if you can see my screen, you can see that I've got this I love vVols here. With each release, especially in vSphere 8, you're going to see a lot of focus on vVols. vVols has become our primary engineering focus on external storage. So we're still doing some development on VMFS, NFS, pretty much nothing on RDMs, I can tell you that right now. In fact, RDMs will not be ported to NVMe over fabrics, but most of the focus has been put on vVols. So make sure when you're talking to your customers that you're talking to them about vVols and that it's something that they should be looking at and possibly adding to their environment. Now, one of the big things that we added in vSphere 8 is support for NVMe over fabrics with vVols. Now, I haven't done my vVols technical overview. Chris and I talked about that. That might be something that I'll do later to dive in. But there's some technical pieces on how this works. We have something called a VASA. The VASA is basically this bidirectional communication between the vSphere environment and the storage array itself. This is an out-of-band. There's no I/O that goes through this. But when we were talking about SCSI before, each vVol object is its own entity sitting on the array itself. So each disk has its own object sitting on the array, and there's nothing below that. When it comes to NVMe over fabrics, we're similar in that, but the way it's instantiated on the array is a little bit different. We now have something called the storage container that's an NVMe subsystem. Now, the NVMe subsystem, I purposely have two of those on what would be the storage array because it can be a little bit different per array, but that NVMe subsystem equates to what we call a vVols storage container. The storage container equates to 1-to-1 for a vVols data store. So when this is provisioned, which a lot of this is very automatic, especially with NVMe over Fabrics. So customers using NVMe over Fabrics with vVols don't have to really do a lot of setup. There's a little bit different in the way the vVols are actually instantiated. We have this ANA group, which is an asymmetrical namespace access. And within that ANA group are the actual vVols themselves. Now, what's different about this versus SCSI is that each vVol is now an NVMe namespace. So here I have a couple of arrows pointing to two separate namespaces. The first one being what would be VM home or the config vVol, and the second one being a VMDK. So every VMDK that's added to a VM is going to be another namespace, and it's going to have a direct IO connection to those objects. Now, what's different about vVols on NVMe over Fabrics is on SCSI, we have this thing called a protocol endpoint, which is kind of a proxy to the actual names, to the SCSI objects. But in NVMe over Fabrics, what's different about this is that that PE is now what we call a virtual PE. And it actually is not a physical object that you would normally see like you would with SCSI. When the first VM is provisioned and powered on in that vVols data store, that VPE is automatically created. The customer does not have to do anything to set this up. So now you can see the VPE points to that ANA group. The ANA group is the logical grouping of the namespaces, and then that's contained within that logical container, which is the vVols storage container. Now, similar to SCSI, that storage container is not a physical object. It's an allocation of space. So when you set up vVols in the environment and you do an initial provisioning, regardless of how much space you allocate, there's nothing physically created on the array. And this is the same for both NVMe or SCSI. So when that's provisioned, until an object is actually placed in there, a VM, you won't see any storage utilization. So when that first VM is created or provisioned or storage vMotioned into that data store, then that's when space actually gets utilized, and it's only the size of those disks. So if you provision 10 terabytes and you put in a 10 gigabyte VM, you're only going to see 10 gigabytes used. So there's a lot more efficiency in the way vVols utilizes the space. I'm not going to go into too much detail on that. I'll save that for my vVols deep dive, but that's a quick overview of the newer feature when it comes to NVMe over Fabrics. Okay, so I'm going to hold off on the questions because those are some good questions, and I'll finish those in just a second here. Some other features that were added on vVols, we did some swap improvements. Now, what you're going to see is kind of a theme when it comes to the vVols piece of this, in that it's all been we've been doing a lot of feature enhancements for scale and for performance. So with the swap enhancements, what we've done is increased the performance for power on and power off situations. Now, normally that isn't something that you would ever see, but the idea is when customers have hundreds or even thousands of VMs, and maybe there's a big power on or a power off storm, this helps with that situation. The other one is vMotion. So when you're doing a vMotion between hosts, there's some connection functionality that happens with a bind and a rebind and unbind. We've increased that performance as well. Now, this is another thing that we did that really kind of helped with some of the performance, especially for VMs that aren't super active. we used to have this thing called opportunistically bound config vVol. The config vVol is basically the VM home. And when I mean opportunistically, what it would do is it would bind, which means connect to, that object on PowerUp, do the read for VM home, NVRAM, VMX, whatever it was. And then if it wasn't accessed for a while, it would actually unbind it. Well, the problem with that is that if a VM goes to get accessed and it has to read any of the logs, NVRAM, whatever, it would have to rebind, and that would cause a little bit of a latency issue. So what we've done now is make the config vVol stay bound. And so that greatly helps performance anytime a VM is possibly a little bit stagnant and then needs to get read or something gets done later. So again, looking at performance improvements and scale when it comes to vVols. Now, another thing we did, this is kind of going into just VMFS in general, is that we've added a lower reclamation rate. So before, the default was 25 megabytes per second. We have seen in some cases in really large environments when customers had what we call a power off storm. This is an example. 100 data stores, 40 hosts, power off a whole bunch of VMs. And what happens is all of those swap files have to get cleaned up. And you can get upwards of 100 plus gigabytes per second reclamation rate. That's obviously pretty high bandwidth and can actually impact a lot of arrays, potentially even some flash arrays. So what we've done is added an additional lower reclamation rate that customers can now choose in those environments that have maybe really high churn, or in sometimes VDI environments where you do a power off storm, you can actually lower that to 10 megabytes per second. Now, something I do like to mention, because this is something that has come up before, is that in some cases, customers want to disable this. You don't have to change anything or re-provision. I haven't heard this recently, but I did hear a customer go back to VMFS 5. Please don't do that. Stay on VMFS 6. That's where all our advancements are. You can just go into the data store and disable space reclamation if there's extreme churn on that data store and it's impacting the array. So keep that in mind. But this is something that was released in vSphere 8. Some other NVMe enhancements. We increased the namespaces for TCP and FC. We've also done some extend reservation support. So what this means is that for customers that are trying to get off RDMs, right? See, no RDMs. We've added reservation support. So this means that customers that want to use NVMe over Fabrics and a VMFS data store can now use that clustered VMDK functionality on NVMe over Fabrics. So this is something that, again, we're trying to help customers find ways to get off of RDMs, especially because there's so much overhead in managing them, and you limit a lot of the features that you have when you're using those. Now, another thing that was added is advanced discovery. Now, this is an NVMe TCP specific feature that if the array supports advanced NVMe discovery and it's turned on when you go to provision a data store and you have to add the controller. If you don't have advanced discovery, you have to manually add the controller and then connect to it. With advanced discovery, you can just hit discover and it will go find that controller and add it automatically. So this is trying to simplify the process. Now, this is NVMe TCP specific, so it doesn't work for FC or RDMA. Couple of container storage functionalities. We added the capability to use SPBM to select or define specific provisioning types. So now we have these 3 new provisioning names, but to make that simple, this is what they equate to. So fully initialized is eager, thick, reserved is lazy, and conserve where possible is thin. So the idea here is that when customers are using K8s or CSI or Kubernetes or whatever it might be, they can set up a SPBM policy, and when they provision that PV or that PVC, they can then select whether they want that eager, thick, lazy, or thin. So just, again, enhancing the way we manage storage within the vSphere environment. Some additional enhancements. We added some NFS resiliency. So this helps with when you're setting up the data store. It can try a remount, basically, if the initial mount tries to fail. We also added NFS mount validation. So once it connects, it makes sure that the connection is secure and valid so that customers don't have to go through and do some additional testing. All right, so that's that section. Let me go over here and take a look at some questions. We have an ETA on vVols will support NetApp SnapMirror Active Sync. I don't have an ETA on that yet. I can tell you that NetApp is very active on vVols development. In fact, most of the storage vendors are all very active. So that's very good to hear, but I don't have an ETA on NetApp's support for that. The difference between vVols FC and NVMe over Fabrics. So the difference is just going to be if customers wanted to use NVMe over Fabrics to try and get some enhanced performance. Now, the vVols does support NVMe FC, so that is supported. There's going to be, if you've got end-to-end setup, which you'll hear me talk a little bit about more NVMe functionality, you can get some enhanced performance because you'll be using the NVMe protocol. FC is obviously going to be pretty fast, but if you use FC, there's some benefits in the way the NVMe protocol works, just in general, that is going to probably give you a little bit better performance. For NVMe over Fabrics, do you need VMs with NVMe controllers? So I'm going to dive into a little bit of that in here in a bit, but no, you do not. In fact, when your customers, if they're looking into NVMe over Fabrics and they want to use the vNVMe controller, you want to make sure that, one, the guest OS supports it, and two, there's going to be a reason to use that. And you got to be careful because there's certain vSphere releases, which you'll see here in just a bit, that support certain features. So, but the quick answer is that no, you don't have to use an NVMe controller, even if you're using an NVMe over Fabric data store. ETA for Horizon Instant Clones to support vVols. So the way that's a little different on how the Horizon client works, because each vVol is not going to be a linked clone, right? They'll be full clones. So in instance, they don't support, there's no plan to change that linked clone functionality. The instant clone is basically a full copy because if you remember, if you're familiar with vVols, vVols are basically just objects on the array that are either LUNs or files, depending on if it's block or file or a namespace. And doing a copy or a clone is an array-based option or array-based action. So when you do a clone, it's very quick. It's a metadata operation. So you're not going to see specifically where you go in there and they do this linked clone or instant clone functionality. It's just a full clone the way it works, because you don't want to share that piece because each vVol object is dedicated to a specific VM. So hopefully that answers your question. Really, the idea is that you just do a full clone. but the difference is on the back end, it's not going to be, it'll be a copy, but it's still going to use metadata and dedupe and compression on the array. So you're not going to end up with, say it's 100 gigs, you're not going to end up with a bunch of 100 gig disks. You're going to end up with a bunch of metadata copies. Will you require a minimum performance requirement for the VASA? So currently for vSphere 8 is your minimum for NVMe over fabrics. That is VASA 3.5, I believe, if I remember correctly. Yeah, 3.5. And so that will give you that functionality there. Now, you're going to hear more about the VASA updates that we've done, and there's been some substantial VASA performance. In fact, update 1, the next one, you'll hear about those right now. So let's jump into update 1. Again, starting off with vVols and talking about VASA, we added a new VASA in update 1, and the VASA is now VASA Spec 5. So for those that are interested in or want to know about the VASA has a release that sometimes correlates with a specific vSphere version and sometimes can be independent. VASA 5 is very dependent on update 1. Now, what's unique about the VASA 5 is that there are some features that customers can get with VASA 5 and update 1 without having to have the array support VASA 5. So it was a pretty big update. It had to do a lot with management and functionality and laying the groundwork for stretched vVols. I'm sure you guys have heard, if you've heard anything that I've been talking about or some of the other vendors, there's a lot of active development. It's one of our primary focuses right now is to get stretched clusters. So hopefully you'll see that sometime in the near future. But the whole idea with the VASA 5 was a couple of things. One was certificate management and also supporting multiple vCenters. So part of this was this server namespace, server name indication, and that has to do with the transport layer and some security and being able to support multiple vCenters. So I'm going to go through some of the feature functionality that was added with VASA 5. One of the first things was container isolation. This helps with the storage container isolation across multiple arrays and multiple vCenters. Again, this is laying the groundwork for that stretch vVols functionality. Better uptime. So again, this is allowing for redundancy across the VASA provider if it's on multiple arrays. Some enhanced security. So this was something else that we added when it comes to better security, better TLS. We increased the TLS on the VASAs. Backwards compatible. So this is, again, where customers can upgrade to update 1, even if the array doesn't support VASA 5. Heterogeneous certificate management. So managing certificates across multiple arrays and multiple vCenters. Zero user intervention for a lot of these features was a big thing. Workload separation. So this has to do with being able to separate those workloads across different vCenters or different arrays. And then also some security and compliance when it comes to, again, that stretched vVols functionality that we've been working on for quite a while. Now, one of the big feature adds, and this is one of the features that comes automatically when you upgrade to update 1 if a customer is using vVols right now. If a customer needed to upgrade the VASA provider or the storage provider, this is something that you see in the vCenter itself. The previous process was to go in and remove the storage provider and then re-add it. Now, the problem with this process is that when you remove the storage provider in vCenter, the data store goes unavailable. That makes a lot of administrators very nervous, including me, but I've done it many times. There's no impact because the actual IO is between the hosts and the array, not within vCenter. So even if you remove the storage provider and you've got active connections, that will not be impacted. Now, while that VASA or that storage provider is unavailable, you won't be able to do any management. So you can't do vMotion, you can't create new VMs, power on VMs, change storage policies, create new storage policies. So there's some management limitations, but the IO will continue to operate. Anyway, that process was kind of unnerving. And what we've done is changed the way that that is handled now. If you go into the storage provider screen, you'll now see this little icon where it says that a new VASA is available. Now, rather than having to remove and re-add, what we've done is change the process where now you can go in and just do an upgrade, and it will cycle the connection and then upgrade the storage provider. So now you won't see your data store go unavailable while you're trying to do a VASA upgrade. So again, this is enhancing the management of vVols themselves. Now, another thing that we changed is one of the vVol objects is called a config vVol. The config vVol is the easiest way to describe it is a VM home. We've done two things, is change this from VMS 5, which is an old architecture, to VMFS 6, but we've also changed it from 4 gigabytes to 255 gigabytes. Now, all vVols are typically thin provisioned. Even when you select thick, most array vendors, especially all flash array vendors, are going to disregard writing zeros. And there are some customers that might say, well, I need thick for performance because of the first write performance impact. With vVols, that first write issue really isn't an issue because it's not sharing an object. vVols are dedicated to a VM, and they're not sharing a LUN or a volume. So when that first write happens, it already knows exactly where it's going to write it. It doesn't have to try and find space within a LUN or a volume that's being shared across multiple hosts with, possibly hundreds of VMs. So that first write impact is negligible. You don't even notice it. In fact, we've done performance and not even seen the performance impact of that first write. Now, some customers get concerned that they say, well, you're going to be provisioning all these 255 gig files. But if you look here in this example, the utilization is 1.9 meg. So it's very tiny. The reason we increased this was to enable a couple of functionalities. One was to be able to use the config vVol as a content library. So now customers can use vVols as a content library in their environment. And then another function was when we would provision vVols, we had this thing called a sidecar file. That sidecar file, which is not visible anywhere, was basically some diagnostic and some pointer information for each vVol object. The problem was that was another object count against the array. So what we've done now is there's a config vVol that gets created on the data store, and now all these sidecar files get put in that first config vVol. So now we reduce the object count against the array itself. Now, there's a little bit of a knowledge base that you need to understand if you've got customers that are using vVols and are going to upgrade to update 1. This is not backwards compatible. It's not a problem because the 4 gig can run on update 1, no problem. But if you provision a VM in update 1 and try and go back to anything below update 1, it's going to fail. So the key is just make sure that if your customers are going to be upgrading, that they upgrade all their hosts before creating any new VMs. So existing VMs are still going to have the 4 gig, new VMs are going to have the 255 gig config vVol. So it's just a process. It's not that anything will break. It's just that if you say a customer upgrades half their environment, creates some new VMs with a 255 gig and tries to put a host in maintenance mode, and there's only a host available that's not update 1, it's not going to be allowed to move to that host. So just make sure that customers upgrade everything before creating any new VMs. Some other enhancements that we did, we added NVMe TCP support in update 1. So now as of update 1, we support FC and TCP. It's still the same basic architecture in the back end, just using a different transport. Some other enhancements. Now, this is where that question came up about reverse compatibility and using the vNVMe controller. Now, just to give you a quick backstory on NVMe over Fabrics, which was added in vSphere 7, we created a new storage stack. So the original SCSI stack is called the PSA, Pluggable Storage Architecture, and that was dedicated to SCSI, and it had a lot of processes and commands and calls. And then we created this new NVMe specific stack called HPP, High Performance Plugin. And that is dedicated to the NVMe protocol. To give you an idea of how much faster these stacks are, is the PSA stack is usually capable of a maximum of about 400,000 IOPS. The HPP stack, because it's NVMe only and optimized for the NVMe protocol, is potentially capable of up to 1 million IOPS. So substantially faster. Now, obviously that's very hard to get on a single host without some pretty doing some trickery, but that just gives you an idea of how much faster this stack is. So in update 1, one of the big things that we added is end-to-end NVMe. So if you provision a VM with the vNVMe controller and the guest OS supports NVMe, and you place that VM on an NVMe data store, you will actually be using the NVMe protocol from the guest OS to the storage target. So this is going to give you your maximum performance. This is supported for both TCP, or for all of the protocols that we support, which is TCP, FC, and RDMA. So this is something that some customers are looking into to get maximum storage performance. Now, the next piece of this, and this is the most simple diagram I could create, is this kind of helps to understand how this can work functionally. Now, there was a question about the vNVMe controller running on SCSI or vice versa. Part of the reason this took quite a while is that we've created this thing called the FSD, or the FDS, excuse me, and the file system device switch will take the protocol or the connectivity and basically allows for any combination. So a VM using a vNVMe controller can be put on a SCSI data store, and vice versa. A VM using a SCSI controller can be put on an NVMe data store. This will take care of any translation in the back end. Now, obviously, if you were to put SCSI on NVMe or NVMe on SCSI, you're not going to get maximum performance, but it will still work. There's no impact. So it allows customers to migrate existing VMs onto an NVMe data store and potentially get a little bit better performance. And then customers wanting maximum performance can build new VMs. You cannot convert an existing SCSI VM to an NVMe VM. So you can't go in and change the controller. Remember, SCSI is a completely different protocol. It writes different, so you cannot convert those. You have to build new. But it will support putting SCSI on top of an NVMe target. A couple other enhancements, increasing max paths per namespace. increasing the amount of Microsoft WSFC clusters per host. So for the longest time, this used to be 3. Now you can do up to 16 clusters per host. We've also enhanced Xcopy across different arrays. So this is a SCSI functionality. This is array specific. The array has to support the initiative, but this can allow for increased performance when you're copying across arrays. Now, another one that was added, and this is something that, in my opinion, should have been added a long time ago. But now when you're setting up an NFS data store, you can go in and do a kernel bind. So this helps to make sure that that NFS protocol is going across a specific NIC or a specific VLAN that you want it to go to. Previously, the best practice was to create a VLAN and a port group that was on the same VLAN or subnet as the array, and typically the protocol would find that and use that path. By using port binding, now we can ensure that the NFS traffic goes through a specific NIC and a specific VLAN and subnet. Some other enhancements on update 1 for Tanzu. Supervisor services can now use a VDS switch. The Linux supervisor support for all Linux images. Some web console support and support for thick provisioning on the CNS. And again, that's using that SPBM policy. All right, so now let's stop and answer some questions. Second here. Is there a release date for update 1? Well, update 1 has already been released. That was released, gosh, I don't remember the date, but update 1 has been updated out for a while. So you can get update 1 now. So then to fix legacy 4 gig, you have to do a storage vMotion. No, so once a VM has that config vVol, it's not going to change. So VMs with the 4 gig are just going to continue to use the 4 gig. You can't change that. You'd have to provision it new. And it doesn't change anything for the VM. There's no performance increase or anything. It's for other features within the data store and functionality. So initially that 4 gig is, and if you look at it, that screenshot that I had before, that 4 gig, again, is still, it was only using a, less than 2 megabytes. So they're very tiny. Increasing the size of a shared disk online with vVols. Is that supported now? How about I go to the next section and you'll find out. So update 2. Update 2 had some really exciting announcements, as we just alluded to that. We'll start off with vVols again, because again, it's our primary focus. And in update 2, this was something that was requested a lot and something that I had been requesting for years. And really, this is part of getting rid of RDMs. In update 2, if customers are using vVols and shared functionality like Microsoft WSFC or Oracle RAC, they can now hot extend those disks. So the whole idea of this is, again, no RDMs. This is the last nail in the coffin for RDMs when it comes to vVols. This hot extend with the application, the shared clustered application online, was the only function that RDMs had over vVols before update 2. So now, as of update 2, RDMs have nothing over our vVols. Now, the nice thing about this is that now customers can migrate, and I have a whole article out on core.vmware.com. Just search for vVols and WSFC on migrating a WSFC from physical RDMs to vVols. The nice thing about doing the migration is that there's no application changes. If you've seen any customers that have tried or that have migrated a WSFC from RDMs to clustered VMDK, you'll notice that there's a few application changes, some timeouts that have to be changed. With vVols, there's no change at all because they essentially work very similar to RDMs. So migrating is fairly simple. You do have to power off the cluster. It does have to be powered off, but the process is fairly simple. And again, there's no application changes. So this was a huge announcement. And I can tell you that I've even got a demo on the announcement on, again, out on Core, the Tech Zone. And it's like changing a regular disk. You just go in on the primary node, resize the disk. You go look at all the other secondary nodes, and the disk has been updated on that shared disk. And you go into the application, go into disks, and it already shows up, and you just extend it and you're done. So it's a super simple process, but there was a huge amount of work on the back end. So this is something that we were really excited to announce to help customers get off of RDMs. Some other enhancements is vVols NVMe in-band migration. So the big difference between NVMe and SCSI is that SCSI is pretty much static. There's not a lot of development within the SCSI protocol. NVMe, on the other hand, is continuously being developed. And there's a lot of opportunity to do some in-band functionality, which reduces a little bit of the overhead of having to go out through the VASA. So by doing some in-band functionality, we can increase the performance and reduce latency. So there may be some additional features that we add in-band within the NVMe over Fabrics functionality for vVols. Some other enhancements is automated recovery from PDLs on the vVols PE. So this is SCSI specific. In case of a permanent device loss, if the PE, which is a physical object on the array, is unavailable and it comes back, we've got some automated recovery to get your VMs and vVols back and accessible. Now, this was a request from one of the vendors wanting their multi-pathing plugin supported. So we added some third-party MPP for NVMe vVols. There's also some unmapped support. So remember in update 1, we talked about that new config vVol being 255 gig. The thing that we needed to make sure in add was unmapped support for that vVol, that config vVol, because now it's being used for other functionality. So if a customer uses it for a content library and they're adding and removing objects or ISOs or whatever it is they're adding into that content library, without unmap, that config vVol could potentially fill up. So what we've done now is added automatic unmap for that config vVol in that case. Some other enhancements is Oracle support for the vVols shared disk functionality. So we talked about the SCSI specific piece on the hot extend. For vVols, for Oracle Rack, it actually works for both NVMe and SCSI. So customers using Oracle Rack can now, same thing, resize a disk that's shared in that environment, both for SCSI and NVMe. Some other NVMe enhancements, support for the vNVMe controller for Microsoft WSFC. Now, I don't remember offhand the specific OS version, but there is a specific OS version that also has to be used to support that. So you have to make sure that guest OS supports it, but we have validated with Microsoft that now the vNVMe controller can be used with the WSFC itself. Also, like I said, the Oracle Rack functionality support for clustered vVols, and then enhancing Oracle Rack NVMe support with vVols. So we've got TCP, FC, then we've also got SCSI when it comes to Oracle Rack. Some other enhancements, some improved SE sparse snapshot offline consolidation. So when you create a snapshot on VMFS, we create a new disk, or a Delta disk is what we kind of a nickname for it. It's actually an SE sparse disk. And this helps when there's doing replication functionality for RPO and RTO. It'll clean up that disk and that snapshot consolidation. We've also added some DNLC. So this is some dynamic caching functionality for 4.1. 3.0 already had it in the environment. So what this helps for is if you're going and doing any lookup instructions, lists, rather than having to go and actually do that process, which would obviously increase latency, we now have that process where it's already got a cache of that list or lookup functionality. So again, trying to reduce performance impact. Another thing that was added is NConnect. So we've added NConnect for NFS. NConnect was added previously for 3.1. Now we've added it for 4.1. Or excuse me, this one is actually 3.0. And what this does is allow multiple connections, multiple basically channels from a single IP. So a lot of times this is used in the cloud environment, but it can be used on-prem. Initially, your connection per IP is going to be 1. The maximum default is 4, but you can increase that up to 8. So there's a lot of performance improvements that can be done with NFS 3.1 with that NConnect functionality. So I have a resource page that I create for all of the vSphere 8 functionality, and now we'll go back to questions. So in 8.0, why can I only see VASA 4? I don't see the option for VASA 5. So you're not going to see the option for VASA 5 because that when you see it on the storage provider, that means the array supports it. So the VASA 5 functionality is in update 2, but the VASA storage provider connectivity is going to rely on the array itself. So you won't see that until the array supports that. So it's kind of there's two pieces there, right? You've got the vSphere, what it supports, and then you've got the storage array itself and what it supports. So like you can upgrade to update 2 or update 1, and you'll still see VASA 3 on an array because that's as far as they've developed or where their spec is. Is there any more questions? And like I said, all this information is out there on this link. So if you want customers, it's public, so you can show this to your customers. You guys can use it. There's a lot of, like I said, I've got how-tos out there on that migrating from RDMs to vVols for customers that are interested in doing that. See version 3 and VASA API 4, so I wasn't sure. Yeah, so it's weird. All of that on the storage provider is being reported by the storage array itself. So it's a little different versus, each update. Sometimes we do VASA updates that the vSphere supports, and then the array has to then support that. All right, Chris.
Great.
Back to you, I guess.
Yeah, thank you. Let's see. Oh, we're getting some more questions here. Let's take a look. Looks like that link doesn't work. Let me check that real quick. See if I can get there. Okay.
Failing. If you just go to core.vmware.com, you can find this stuff. There's been a lot of changes on the VIA functionality. I've actually switched some of this stuff over to Bitly. So it's just on core.vmware.com, and there's a resource. There was some limitation on vVols with NVMe. So yes, there was initially there was FC only support, and then we added TCP. As far as compared to SCSI, there are a few minor storage actions. Xcopy, which is a write same or a copy on the NVMe. I can't remember the initiative. That was one of the features that wasn't supported. But you should see that. Hopefully that's something we're working on. So hopefully that's something that we will add in the future. So when you're upgrading vVols vSphere 7 going to 8 update 2, you don't need to worry about compatibility until the storage provider upgrades. Yes. So even if you were to upgrade from 7 to update 2, and then 8.0 U2, you're not going to have any impact to anything on the back side. So even if the new VMs are created and the array is still on VASA 3, it should still work. We made sure that it was backwards compatible in the management functionality. Remember, just the VM. So if you create a new VM on U2, you can't migrate back to anything below, or U1, excuse me. If you upgrade to U1, you can't do anything backwards. So just keep that in mind. It would be the same for U2 as well. So if you upgrade from 7 to 8.0 U2 and create a new VM, it can't go back to an older host. Just keep that in mind. That's why I say just make sure that you upgrade holistically, like upgrade your entire environment before creating any new VMs if you've got vVols in your environment.
Okay. I don't see any other questions. We'll go ahead and start, kind of exiting out of here, but we'll be on the lookout for any questions that pop up. So, Jason, really appreciate you going over this. This is a great topic. It's really useful content. For everyone on the call, just as a reminder, this session has been recorded and it will be made available to you by your TAM. And for those that are interested in a more detailed exploration of vVols, Jason mentioned and has offered to present on this topic. If you're interested in that, please be sure to express that in the survey, along with any other topics that you're interested in. We greatly appreciate it. So we invite you to join us for our next session on July 11th. We're going to explore Edge Compute Stack in that session. We look forward to having you join us. Thank you once again, everyone, and take care.
Thanks. Thanks for tuning in.
Yep. Thanks again, Jason.
My pleasure.